Today, let's have some fun with OSPF designated and backup designated routers. Today we are using a different setup. This is called Cisco Modeling Labs, or CML. In a future video, I will discuss two different ways to get your hands on this. This used to be called VIRL, VIRL. Came out like 2014, 2015. Can't remember the exact year, but I've been using it ever since then. And like I mentioned in a future video, I will discuss two different ways for you to get this, one free and one paid. But let's get started. In OSPF, if you can see here, I have a nice setup here with 11 routers and one switch, and all the routers are plugged back into the switch. That's what we have here. And as you may know in your CCNA, CCNP studies, in a multi-access broadcast network like this, OSPF needs to select a DR and a BDR. DR, designated router; BDR, backup designated router. There are a number of reasons we may want to select our DR and BDR. In our example, we really want R1 and R2 to be the DR and BDR. For example, you may want your beefier routers to handle this task. So pretend that R1 and R2, even though in this lab setup, they're all running the same iOS, the same type of router. But let's pretend that R1 and R2 are your massive routers with CPU and memory. They can handle anything. And just imagine that the rest of the routers are just smaller routers. Yeah, simply put, you have your routers at the edge of the network, and there is no reason why they should handle the task of being the designated or backup designated router. Yeah, that's just simply it. You don't want, for example, R3 to be your designated or backup designated if it's at the edge of the network, very isolated, with the possibility that their circuit may go down. It's very unstable. You never want that one to be the one that's powerful. So right off the bat, let's go here into our console and bring this up a little bit. And we are on R1. And of course, I typed in the wrong command, so now we have to wait. So let's go to R2. This is live, not editing anything. So if I do a show IP OSPF neighbor, we could see that we have our 1, 3, 4, 5, 6, 7, 8, 9, our two-way DR other. So when a router is not the DR or BDR, it's called a DR other, druther, like kind of like pronounced like brother, but with a D, and or just DR other, meaning it's not participating this time. So you could see that router 11 is the DR right there, full and DR. Router 10 is full and it's the BDR. Why are these two DR BDR? What is the DR and BDR selection process? The router with the highest OSPF priority will usually become the DR, and the router with the second highest OSPF priority will become the BDR. But here's the thing, we haven't established any priority. They're all set at default. So there will be a tie there. So in case of a tie, the router with the highest router ID wins this election process. So of course, it's using 11.11.11.11 as its router ID. We only have one interface configured on each of these routers, which is G00. The highest router ID is 11.11 and so forth, and 10.10.10.10.10 is the second. So that's why it's, and the interesting thing about this, it's that there is no, preemption. So what I did, I started all these routers at the same time so that they could all participate. But if I had just started R1, R2, R3, R4, R5, and then let them completely boot and do the OSPF DR BDR process, it would have picked 5 if 5 was the only one up. If after some time I turned on R11, it would not become the DR BDR because it's not, like I said, there's no preemption. It's not preemptive. It's once it's established, that's it. It doesn't change until we clear the IP OSPF process. So let's go back to R1. Okay. And what does this have in it? They should all agree. Correct? And there you have it. 2. And what I did is I put 2.2 is the loopback address. So all of these have that interface as well. I mentioned that we only had the connectivity to G00, which is true, but I enabled OSPF on all routers. So if I do a show run section router OSPF, you can see it. I enabled OSPF on every single interface, and I created a loopback interface on each router. It represents their router number. So 2.2.2.2 is router 2, 3.3.3.3 is router 3. Okay, so how can we force it so that R1 and R2, which are your most powerful routers, and they're centrally located and they're just available all the time, they just do not go down. How can I force these two to be the DR and BDR? Well, a simple way is to change the router priority. So if we go to router 11, I could force this to not participate in the OSPF process. So simply go to IP interface G00, and we do an IP OSPF. And you see priority, router priority. That's what we want. Okay, priority. And if we put a 0, I wish they would explain this here, but 255 means it's going to win the battle. So IP OS priority 0. And now let's do a show IP OSPF neighbor. And you see what it just did? It just made router 10 the full DR BDR. Now remember, I said it doesn't preempt, but when you set this configuration command in there, it does remove him. So that's a difference there. It removes him as being the DR. Now let's go to router 10. Let's see what happens here. Let's do the same thing. Interface G00, IP OSPF priority 0. Okay, bam. Show IP OSPF neighbor. You see what's happening here? It goes, once you put that command in there, it kind of resyncs and says, hey, I'm not part of this process. I'm not part of y'all. So then that's how it picks 9 and 8. And we can just keep going down the line doing this. IP OSPF priority. And you have to put at least, if you look at it, PR. So you have 2 commands that start with PR. So you have to select PRI, and then you could just do that. And once again, show IP OSPF neighbors. And once again, it shows it there. And we keep going down. See, it took a little bit for the process to happen. And now it's selected 8 and 7. Pretty cool, huh? So let me just finish doing all of these until we make R1 and R2 the OSPF winners. But let me change something real quick here. So we always want this interface to be the winner. So we set up ISPF OSPF PRI for priority, and let's make it, what's the top number? 255, correct? So remember, if the selection process happens, the router with the highest OSPF priority will become a DR. Router with the second highest OSPF priority will become the BDR. But then if there's a tie, which there was because there was no extra configuration, all the routers had the same OSPF priority. So it went by the router ID. R11, of course, because if its highest IP address on loopback 0 became the DR and then 10. So right now we're setting up R1 as with the highest priority. So let's take a look at what happened there. Show IP OSPF neighbor. If you notice, it didn't do anything. So remember, it doesn't preempt. So router 8 has not said, yo, I'm not part of this. It only does that if you set the priority to 0. So where did we leave off? We left off on 8. So let's go back to 8 and let's configure this. Interface G00. And now remember, R1 now has a priority of 255. So interface G00, and we'll put ISPF, OSPF priority 0, saying I don't want to participate. I don't want to deal with you guys. You guys tell me what I got to do and I'll do it. Take a look. And if you look at this, it shows the neighbor ID. What's the priority on 1? 255. So router 8 already got a packet, a notification saying, hey, I have the top priority. So what will happen if we keep running this command? So router 7 is the DR, and now router 1 is the BDR. And why is that? It's because router 7 was already the backup designated router. So remember, the rule is if the DR goes down, the backup designated router or the BDR takes over. And that's exactly what happened. So let's go to router 7 and let's take them out of the equation. Remember, now router 1 is the backup designated router. So let's come in here, interface G00, IP OSPF priority 0. Let's take them out of the equation. And let's just keep moving forward. Let's just keep changing them. Interface G00, IP OSPF priority 0. And yes, you have to do this on every single router. That's the way it is. Show IP OSPF neighbor. So you can see now, router 1 became the DR. Router 5 is still the BDR because it's the next highest IP address or next highest router ID. So let's just go in here and enforce this guy to be the second, to be the BDR. So this will have an IP OSPF priority of 250. What was it? 255 is the number. So router 1 was 255. Let's make this guy 254. Show IP OSPF neighbor. And it's thinking about it. And once again, please click that notification bell. Please subscribe to the channel. It just helps me out a little bit. I also have a buy me a coffee link on the bottom there. So if you want to buy me a coffee, I love espresso. So send that over my way. I'm going to keep producing these videos for you. Let's see what happens here now. Full DR, router 1, and the BDR is still 5. Once again, remember, the BDR always becomes the designated router. That there's no election process there unless you take them out of the equation. The way to take them out of the equation is by doing this. So IP OSPF priority 0. Now we took them out of the equation. Let's open this. And I just love the way Cisco Modeling Labs works. It's just very quick. Sometimes you might have little issues here and there, but hey, it's not easy to get all these router configs and router models in there. Router priority 0. Take them out of the equation. Show IP OSPF neighbors. And now you see that we have these two, router 1 and router 2. And you can see their priority. So by default, the priority is 1, which is not very high. And obviously it's set that way so that we can play around with the priority. I can make R1, R2, and maybe R3 have 255 on R1, 254 on R2, and R3 could be 253. And that'll be your selection process. Configure interface G0, IP OSPF, priority. And like I said, let's make it 253. Give this guy a chance. And it's not preemptive because I didn't take him out of the equation. He is part of the equation. So what happens if I then come over to router 1 and I shut down the interface? Configure T, interface G00, shut. What happens on router 2? So it takes a minute. And it still takes a minute, still doesn't realize that it's down. And that's why we would establish other things, other methods of notifying each other. Remember that there are timers. So that could be a future video for you. I will establish timers and we'll talk about this, the IP OSPF hello and dead intervals. So those timers are very important on these networks. Well, that is it for this video. In a future video, we'll keep going over OSPF and playing around with it. It is just such a good protocol, quite complicated in the way we can set it up. And if you just don't want to mess around with having a DR, BDR, there's another way to get that working. And in a future video, I'll discuss that as well.